Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We will finish up section 4.7 with this video set of notes, and it's going to involve, again, a topic that we looked at during first semester with composition of functions. Now, going back to what we did during first semester, if you find f inverse of x, meaning if you plug the inverse of a function into the original function, it will equal x. And along those same lines, if you look for f inverse of f of x, meaning plug the original function into its inverse, it will also equal x for all x in the domain of f and its inverse. So, which, would follow, again, when you see arcsine, that's again the same thing as sine inverse. Sine of arcsine of x will equal x, and arcsine of sine of x will equal x. Now, the big issue here will be some domains, and one of the things that we're going to list here, and I actually even like to list both domain and range for all of these. Now, just a regular old sine wave, domains negative to positive infinity. The range, -1 to 1. For arcsine, this is what we found in the last set where we just limited the domain of the original sine wave. So your domain's -1 to 1. Your range for arcsine was -π/2 to π/2. All right, cosine. Well, with a cosine wave, I mean, again, if you have a full wave, domain's negative to positive infinity. Range is also -1 to 1. Well, with cosine, we were able to restrict it for the inverse or arc function to 0 to pi. So, domain of arc cosine is -1 to 1, range is 0 to pi. And then for tangent, let's go ahead and at least the two that we already have. For arctangent, -infinity to positive infinity, the range -π/2 to π/2. Well, as far as our original tangent waves, the range is negative to positive infinity. Our domain is that x can't equal the -π/2, 1π/2. The next one would be at 3π/2. X cannot equal n π/2. I'm not going to write in the fact that, yes, n does need to be an odd integer. We don't really have space for that anyway. But we're now going to talk a little bit about inverse functions. So, if we were to ask you sine of arcsine of 0.7, well, going back to right here, the sine of arcsine of x is x. Sine of arcsine of 0.7, again, those cancel out to 0.7. Arcsine of sine of π/4. Well, again, when you take the inverse of, or you plug the original into the inverse, just π/4. A lot of the times it works out this nicely. And again, basically, here's where this next one, sine of arcsine of 1.5. Now, when you look at this, again, the first two, which I'm now going to actually talk a little more in depth about, if you said, oh yeah, sine of arcsine of 1.5 is 1.5, unfortunately, that is not the case. The reason, you have to look at what is the domain of arcsine. Well, the domain of arcsine is -1 to 1. So right away, this one is undefined or not possible. if we come back up to this, the sine of pi over 4. Well, pi over 4 is in sine's domain. The other thing you do also need to look at is, for the outer one, is it in the range, which yes, it is. If we come back up here, arcsine 0.7. Well, 0.7 is in arcsine's domain. 0.7 is also in sine's range. So that's where, yes, a lot of the time it is as simple and cut and dried as, yep, they cancel out. There's your answer. Yep, there's your answer. Oh, nope, you do have to check the domain of the inner function and the range of the outer function. So one final one, arcsine of sine of 5 pi over 3. Again, seems like, oh yeah, arcsine sine cancel out to 5 pi over 3. Again, you look here. Is 5 pi over 3 in sine's domain? It is. Here's where, again, we run into the issue. 5 pi over 3 is not in arcsine's range. So what we need to do is locate 5 pi over 3 on our unit circle. Now we need an equivalent value that has this y value. Now, the easy way to do that, 5 pi over 3 means we have gone all the way around to 5 pi over 3. Now, the range of arcsine limits us to the right half of the circle. Well, here's the good news. 5 pi over 3 is in the right half of the circle. We just can't go all the way around to get there. We have to take the shortcut negative pi over 3. So that's what makes this section a little bit trickier, is that if it's not in the domain, it's automatically undefined. Here it's in the domain. If it's not in the range, that does not make it undefined. That just means we can find a coterminal value that works. All right, let's look at a couple with cosine. Well, the cosine of arc cosine is 0. Again, if you look, arc cosine's domain, 0 is in it. It's also in cosine's range, so this one is as cut and dried and simple as it's 0. All right, arc cosine, cosine negative pi over 3. Well, negative pi over 3 is in cosine's domain. When you look, is it in arc cosine's range? It unfortunately isn't. So again, it's not just negative pi over 3. What we have to do, well, we just talked about where negative pi over 3 is. It's right there. Now, at 300 degrees or negative pi over 3. Cosine, which is now x, is a half. What we have to do, when we work with arc cosine, its range is 0 to pi, meaning we're only using the top half of the circle. So we need a spot on the top half of the circle where cosine is a half. Well, that spot, because cosine is even, is directly above it at 60 degrees or positive pi over 3. And one last one. I really like this question. It seems like it's it's kind of a trick question here. It seems like it should work because you see pi. Oh yeah, pi's right there. But what you have to be careful about, cosine inverse, meaning arc cosine. Well, look at its domain. It's only negative 1 to 1. Pi, which is 3.14 roughly, is outside of the domain. So this one is, again, undefined, not possible, however you want to phrase it. Because again, pi is outside of arc cosine's domain from the beginning. And one last example. Now let's talk a little bit about tangent. Now with tangent, the range of arc tangent, negative pi over 2 to positive pi over 2. So just like with sine, we are restricted to the right half of the circle. Now, when we look at tangent of arctangent of negative 5, again, the easy answer is it just negative 5 where they cancel? Well, look at arctangent's domain includes negative 5. Tangent's range since they are both negative to positive infinity, it is one of those nice simple ones. Answer is just negative 5. All right, the arctangent of tangent of 5 pi over 6. Well, again, if we look at 5 pi over 6 is definitely not an n pi over 2. So it's in the domain. Now again, here's where we run into our issue. 5 pi over 6 is on the left half of the circle. Tangent restricts us to the right half. Well, y over x, we need the equivalent spot. Well, where that equivalent spot is directly across. Now again, here's where you have to be careful. I know that we're used to positive angles more often than not. 11 pi over 6 is not the correct answer here. 11 pi over 6 is outside of the range. So instead of going all the way around to 11 pi over 6, we have to use the shortcut, which would be negative pi over 6. So again, I know this section has kind of some tricky elements to it because you have to look at first, is it within the inner domain? A lot of the times the answer to that is yes. You know, here it was yes. Is it then in the outer functions range? No. Again, here was one. Yeah, this was inside the inner domain, not the outer range. It's in the inner domain, not the outer range. So you do have to be careful there. If it's not inside the inner functions domain, then it's nice and easy. Yep, just undefined, not possible, however you want to phrase it. So that finishes up section 4.7.